Hello all. In this video we will discuss one example based on equilibrium of a coplanar force system. So unit 3 part A we will see how to determine the reactions developed at supports A and B. So first step is to draw the free body diagram. To draw the free body diagram, at joint A you have a hinge support. At hinge support there are two reactions developed. So at joint A you have one reaction developed vertical at A and one horizontal reaction will be horizontal at A, and at support B is a roller, so it will be vertical reaction developed at B. Then you have a uniformly distributed load. There are no other loads, there is just a uniformly distributed load of 1800 Newton per meter. So magnitude of UDL, uniformly distributed load, is 1800 Newton per meter, and span of UDL is how much? It is from this point to this point. So it is 2.4 plus 0.8, which is 3.2 meters. So if I have to convert it into point load, what will be the value of point load? You take, it is a rectangular load, magnitude into span. So 1800 into 3.2, and it comes out as 5760 newtons of point load. And it will be acting at how much? It will be acting at a distance of 3.2 by 2, which means 1.6 from one end. So if I consider this end as C, वो यहाँ से 1.6 पर act होगा. So 1.6 from this point. If this is 0.8, this will be 0.8, and this entire is 1.6. And the magnitude of this point load is 5760 newtons. Okay, and this distance will be how much? Then this distance is 1.2 plus 1.6. This 1.2 plus 1.6 is 2.8. So this is 2.8. Okay. Now we have to determine the reactions developed at the supports. There are no horizontal forces. What are the conditions of equilibrium available? That is a coplanar force system. We have three conditions of equilibrium: summation fx equals to 0, summation fy equals to 0, and summation of moment equals to 0. Now if I take summation of forces in horizontal direction to be 0, if I take summation fx equals to 0, considering forces acting towards right as positive, there is only one horizontal force, which is HA. So from this you will get HA equals to 0. Now if I apply second condition of equilibrium, which is summation of forces in y equals to 0, considering upward acting forces as positive, I have two upward acting forces. One is VA and another is VB, and one downward acting force of 5760 newtons. So I will have VA plus VB minus 5760 equals to 0. So you get VA plus VB equals to 5760. Let this be your equation 1. You have one more equation remaining, which is taking summation of moment equals to 0, considering anti-clockwise moments to be positive. Let us take summation of moments about point A. So moment about point A equals to 0. हमने anti-clockwise moment positive consider किया है. There are only two forces. One is 5760 and it is going in clockwise direction. So we will consider it as minus 5760 load into perpendicular distance is given as 2.8. So it is 2.8. And another force is VB, which is going in anti-clockwise direction. So plus VB into perpendicular distance up to point B is 2.8 plus 0.8. It will be 3.6. and equals to 0. On solving this, we get VB equals to 4480 newtons, and since it is positive, that means it is in upward direction, and substituting this value in 1, we get VA equals to 1280 newtons, again acting in upward direction. If the directions that we have got while getting the values of VA and VB are negative, that means it is acting in opposite direction of the assumed positive direction. That is how you determine the reactions developed at supports. Thank you.